Assalamualaikum warahmatullahi wabarakatuh. Welcome to our session SMG 3013 Geometry. We are from Group C. I'm excited to dive into a practical and engaging application of geometrical principle today. As you can see from our title slide, our focus will be on parade ground guide signs. Now you might be wondering, what do parade ground and guide signs have to do with geometry? So this is my group members. First, Nuraimi Nabila, Ahmad Zaib, Nurul Asma, Siti Nur Jamaiyah, and me, Nuridina Wafa bin Geometry. Signboards are an important part of our daily life. They help share information, give directions, and catch people's attention. You can see them everywhere, from roads to buildings and shops. There are many types like billboards, LED screens, and shop signs. Each signboard has a purpose, like showing where a place is or promoting a product. Its design, size, and color depends on where it's placed and how far people will view it. For example, a highway sign must be big and clear, while a shop sign can be more creative. Overall, signboards not only share message but also show the identity of the business or place. At University Pendidikan Sultan Idris, the signboard at the parade ground provides essential directions and information to students. The area is also used for training uniform units and hosting official ceremonies. So this is usage of guide sign. First, visual communication are tool. It quickly and clearly conveys information, aiding in fast and accurate decision making. Number two, navigation in educational institutions. It helps students, lecturers, and visitors find facilities, reducing for need and verbal instruction. And lastly, symbolic representation. It visually represents concepts and instructions for efficient communication. So the size of the dimensions guide signs make it easily visible from a distance, ideal for high traffic areas. This large surface also provides sample space for clearly displaying important information, helping new students navigate without confusions. Ultimately, the size and chosen shape are designed to attract attention and enhance the clarity of the message being conveyed. So it is the diagram of our object from front view and from side view. So here is the define of the geometry as a mathematical field focusing on the spatial relationship, size, and magnitudes of objects. It uses basic concepts like points, lines, and shapes to describe arrangements in our surroundings. Geometry is crucial for solving spatial problems fields like architecture, engineering, and physics, and is also key to understanding the universe structure and creating art and technology. So the geometrical shapes. First, we have trapezoid, a four-side shape with a unique configuration. An isosceles trapezoid has equal legs and base angle, making it symmetrical. Its areas is calculated as A equal 1 over 2 multiply A plus B multiply H. Then rectangle, a type of quadrilateral where all four corners are 90 degrees and opposite sides are equal and parallel. Its diagonals are also equal and cross in the middle. Its area is calculated A equal A times B. Next, we have rhombus, a four-side shaped parallelogram where all sides are equal, opposite sides are parallel, and opposite angles are equal. Its diagonals cross at 90 degrees and cut each other in half. Its area is A equal dimension 1 multiply dimension 2 over. Lastly, kite, a four-side shaped quadrilateral with two distinct pairs of equal length adjacent sides. Unlike a rectangle, its angles are not necessarily 90 degrees. Its diagonals are perpendicular with one diagonal, cutting the other in half. Its areas is A equal to dimension 1 multiply dimension 2 equal to 2. Next, rectangular prism. These 3D finger fissures to rectangular bases that are parallel and flat side space. A rectangular prism or cuboid consists of 6 faces, 12 edges, and 8 vertical. Each face is a rectangle and each opposite plane is both on equal and parallel. This shape belongs to the category of right prism, where the sides stand straight out from the bases. The main part of a rectangular prism are its length, weight, and height. The length refers
to the longest edges, the width is the shortest sides of a basis, and height measure the distance from the basis outward. These dimensions describe the full size of the object. Next, let's continue to the geometrical concept. The first object is trapezoid. A trapezoid is a geometric figure with four edges, including a single pair of parallel lines. According to the image, this trapezoid has two congruent sides, which classifies it as an isosceles trapezoid, which is line CD equal to line DA, and the value is 95.5 cm. The base angle of these isosceles trapezoids are congruent, whereas angle C congruent to angle D and angle B congruent to angle A. The parameter of this trapezoid can be measured by adding all the sides of length, which is 406 centimeters. Plus, area of this isosceles trapezoid can be measured by using this formula: A equal to 1 over 2 H bracket CD length CD. With this formula, which is A equal to 1 over 2 H bracket B1 plus B2, which is 8,600 centimeters square. From this image, we have observed that the value of the length, angle, area, and also perimeter. The value of length for line AB is equal to 45, line BC 95.5, and other than that, you can see in this slide. For volume, D don't have any value because the vision is 2D. Next geometry is rectangle. A rectangle is a parallelogram that has a right angle. All angles of a rectangle are right angle, which is angle A equal to angle B equal to angle C equal to angle D. The basis angle of these isosceles trapezoids are congruent. The diagonal of the rectangle are congruent. A quadrilateral with both plates of opposite sides parallel is called parallelogram. And the perimeter of this rectangle can be measured by adding all the sides of length, which is 200 cm. And the area of this rectangle is determined by the formula A equal to BH with base of length B and altitude of length H, which is 1,950 centimeters square.
Next, we are going to talk about the measurement of this rectangle. From the previous slide, we already know about the length, area, angles, and also the perimeter. For example, we already calculate the area by using a formula A equal to BH, and we get 1,875 cm squared. And then for the volume, since this shape is a 2D shape, there are no volume. The next shape is a rectangular prism. Rectangular prism is a three-dimensional solid made up of two identical bases and also lateral face. All of these surfaces together are referred as a face of prism. As we know that all of the sides in the rectangular prism are opposite to the another side. For example, the line segment of AC are perpendicular to the line segment of AE, which means this perpendicular side, which means that this perpendicular side are from a 90 degrees angle. Next, for the perimeter, we can measure the perimeter by adding all of the sides in this rectangular prism, and we will get the answer 1,140 cm. For the area, we can get the area of rectangular prism by using the formula A equal to 2LW plus 2WH plus 2LH, where L is referred to the length, H refer to height, and W refer to width. The area of the rectangular prism is 38,500 cm square. Next, we can calculate the volume since this is a 3D shape by using the formula of volume, which is V equal to LWH, where L is a height, W is a width, and L is a length. The volume of this rectangular prism is 228,000 cm3. From the previous part, we already calculate all of the length, angle, and also the perimeter. For example, if you want to get the perimeter of rectangles with prism, we can calculate it by adding all of the sides of, and the value we will get 1140 cm. For the area and volume, area we already discussed before, and for volume we can get by using the formula of volume, which is length equal to width and height, and we will get 228,000 cm cube.
So next, we move to our fourth geometrical concept, which is a rhombus. So what is a rhombus? A rhombus is a quadrilateral having 4 equal sides, and the opposite angle of it are equal, and adjacent angle add up to 180 degrees. So a rhombus is a quadrilateral with both pair of opposite sides parallel. It's called a parallelogram. And all 4 sides are congruent, which means all its sides are same in measurement. So the perimeter of this rhombus can be measured by adding all of the sides, which is 30 centimeters. The diagonal of the rhombus are perpendicular and bisect each other. The area of this rhombus is determined by the formula d times d over 2, where d1 and d2 are the diagonal of the rhombus, which is 28.15 centimeters square. So this is our geometrical measurement. So we already measured this shape is length, area, angles, and its perimeter. So, for example, we already measured the length of this rhombus, which is all of it are equal, 7.5 centimeter. And we also already calculate the perimeter by adding up all the sides. So we get 30 centimeter. So for the volume, since the rhombus on this thing is in 2 dimensions, so we cannot calculate the volume of it. Lastly, we move to our last geometrical shape, which is a kite. A kite is a quadrilateral with 2 distinct pair of adjacent sides that are equal length. So the opposite angle of this kite are equal. A kite is a quadrilateral with 2 distinct pair of adjacent sides equal in length. So as we already measure it, we get one pair is 5.5 centimeter and one other pair is 2.5 centimeter. So all 4 sides of kite are congruent. As we know, congruence is mean all measurement is equal. So for the perimeter of this kite, we already measure it by adding all of the sides, which is 16 centimeter. And the diagonal of the kite are perpendicular and bisect each other. The area of this rectangle is determined by the formula of d1 times d2 over 2, same as the rhombus, where d and d1 and d2 are the diagonal of the kite, which is 12.16 centimeters square. So this is our geometrical measurement. We already calculate the length, area, angle, and perimeter. So for example, we have calculated the area of this kite, which formula is the same as the rhombus, d1 times d2 over 2, and we get 5.6 centimeter times 4.5 centimeter over 2, which get 12.16 centimeter square. So for the volume, same as the rhombus, we cannot calculate the volume because the shape is in 2 dimension.
There is two transformation, which is transformation in motifs and transformation in patterns. For transformation in motifs, there is kite shape with repetition. The kite, which means a quadrilateral with 2 distinct pairs of adjacent equal sides, is used as a base shape. Its motif is formed through repetition, meaning the kite is duplicated in a sequence, often in a linear or tessellating arrangement. This creates rhythm and continuity in the design commonly seen in borders or tiling patterns. Next, rhombus shape with rotation. The rhombus, which means an equilateral parallelogram, undergoes rotation as its primary transformation. The rhombus is rotated 180, where the rhombus is spun halfway around a central point. This creates symmetry, such as an kaleidoscopic design or interlocking star patterns. We have two transformation in patterns. First, reflection, which is symmetry across an horizontal axis. The observation is the trapezoid ABCD is flanked by 2 identical rectangles. As a central motif which mirror sides, this creates reflection symmetry. Transformation concept is the rectangle as a mirror copies of each other across the trapezoid central axis.
Second, translation, which is repetition of shape. The observation is two rectangles EIGH and JIFG are identical and aligned in a pattern, side by side or step. They demonstrate them translation, the same shape move uniform without rotation. The application is imagine the rectangles repeating across the buildings, facet like tiles, creating rhythm. The summary of this assignment, we have applied the learning information into part A and part B to investigate the structure we selected for this assignment. The structure is the signboard at the parade ground Sultan Azlan Shah campus UPSI. The geometry of the signboard refers to the motifs, patterns, and transformation concepts used in designing the structure. The signboard contains several geometry shapes, which is rectangle and trapezoid are two-dimensional shape, while rectangle prisma is three-dimensional shape. The conclusion is we can see where there are many signs designed with various geometric shape around UPSI, either at the Sultan Azlan Shah campus or the Sultan Abdul Jalil Shah campus. As students, we will become teachers in the future. We need to creatively relate geometry to real life. We can apply this knowledge during teaching in future classes.